Okay, today we're talking about covalent bonds. So we're going to go on with double and triple bonds. All right, this is just an example. You do not have to write this whole thing down. So yes. Yes. Not on focus, but on remind. Okay. All right, so here is a single bond. This one line represents 2 electrons. It represents 1 electron coming from the hydrogen and 1 electron coming from the carbon. Single bond. How many electrons do you think are being represented by this double bond?
4.
4. So 2 electrons in each line. And then how many electrons are here? 6. Again, 2 electrons in each line. And you can see this even more clear here. So there's 1 line, 2 electrons. 2 lines, 4, and 3 lines, 6. Was it?
Not that, but
Yeah, bio has a lot of chemistry in it. Okay, so this is very important. Yesterday we kind of touched on this, but I want you to draw this picture. In this picture, you can see that we have electrons that are being shared between these 2 nonmetals. You guys, up here, please. So nitrogen and hydrogen are sharing these 2. Therefore, we call it a bonded pair because it is bonding hydrogen and nitrogen together. However, this over here, is it being shared between anybody?
No.
No, so we actually call this a lone pair. This lone pair belongs to which atom, guys?
Nitrogen.
To nitrogen, that's correct.
Who wants to write that?
Just the picture. It's very important that you know the difference between a bonded pair and a lone pair. Next slide. So in this, oh sorry, I didn't count. In this slide, you can see I put the different steps to drawing the Lewis structure. You do not have to write this down. We're going to do examples. So for step 1, I'm doing the example for CO3. So how many atoms are involved there? How many atoms of carbon? 1 carbon, because there's no number, so it's just 1 carbon. And how many oxygens do I have? 3. So the first thing you want to do is to put the elements that are involved in that compound together. When you're doing that, if there are 2 or more atoms, in our case, we clearly have more than 2 atoms, you need to pick the one that is the least electronegative. Out of carbon and oxygen, who is the least electronegative?
Oxygen?
Oxygen is actually more electronegative. So I'm going to pull up a periodic table real quick.
Old paper.
Oh yeah, it goes. It
our
increases
periodic
from
table.
left to right, right?
Yeah.
Exactly. So, what?
Yes, nickel.
Oh.
Yeah, remember that old periodic table we had? And how it said electromagnetic activity increases going to the right?
All right. So the closer you are to fluorine, the more electronegative. Fluorine is the most electronegative element. Fluorine. So here's carbon. Here's oxygen. Who's closer to fluorine?
Oxygen.
Oxygen. So carbon is least electronegative between the 2.
Helium is lower in electronegativity.
Yeah, the noble gases are not electronegative at all. All right, so that's why I put carbon in the middle, because carbon is the least electronegative. You're then going to put, the only exception, by the way, guys, is hydrogen. How many bonds can hydrogen make? 1. And if something can only bond once, can we put it in the middle? No, so it can never go in the middle. So here's carbon, and we're going to surround it by the 3 oxygens. Then I'm just going to put the valence electrons. What group is carbon in? It's in group 4, right? So 4 valence electrons. 1, 2, 3, 4. Please remember, guys, when you do your valence electrons, do not go 1, 2, 3, 4. That'll mess you up. You need to go through each cardinal point. So 1, 2, 3, 4. Yeah. All right. Same thing with oxygen. Oxygen is in what group, guys?
6A?
Group 6A. So how many valence electrons? 6. So 1, 2, 3, 4, and then 5, 6. That's very important because if you don't do that, it's going to mess up your bonding. All right, I did the same thing for these 2 oxygens. They have 6. How many single unpaired electrons does this carbon have?
1.
So all of these, 1, 2, 3, and 4, belong to carbon. Are any of them paired up?
Yeah, 3 of them.
Well, before you look at like the oxygen, just
Okay.
looking at carbon. So
Yeah.
I'm just looking at
Oh, they're not.
carbon. Are any of those paired?
No.
No. So how many bonds can carbon make as it is alone? 4. You have 4 dots. Every single little dot represents a possible bond. All right. How about oxygen? How many single electrons does each oxygen have? 2. So there's 1 and there's another one. So this oxygen can make how many bonds? 2. And every oxygen is the same, so each oxygen can make 2 bonds. All right. That's good. We're done with step 1.
Wait, miss. How
Yes.
come you didn't put another oxygen then? Is it because it's just saying CO3?
Exactly, because I only have CO3. Very good. All right, the next question, step 2. We're going to start pairing the unpaired electrons. Well, we just recognized all of our unpaired electrons. You guys told me these 2 were unpaired, so we can just pair them up, and that's what we did. Same thing here, just paired these up and here. However, let me get a different color. We still have 3 unpaired electrons, 1 on each oxygen. And then I have 1 unpaired on carbon. It doesn't matter which unpaired electron you take. It could be from this oxygen, or this one. It really doesn't matter. Later on, we're going to talk about something called resonance, and you're going to see that it ends up being the same regardless. However, I need to take 1 because carbon needs to bond with something, so I'm going to take it from this guy. So when I take this one and this one, I get another bond in between these 2. Questions? Okay, step 3. Now I'm just going to show all of the electrons after I've moved them around. So these 2, there's 2. These 2, there are 2. And these 2 are right there. However, this one and this one are in between here, so I drew another 2. So far, so good? Okay. This would be the Lewis structure, but then I can do one more step, and it's actually better. So wherever I have bonded pairs, I'm going to replace it with lines. So how many bonds do I have between oxygen and carbon? 2. So I'm going to put 2 lines. 4 electrons, right? How many bonds do I have here? So 1 line. And how many bonds in between these 2? 1. Yes, sir.
So could you like double up on either side? Like say like you have double on the left side, could you like switch it and like have double on the right side and single on?
Yeah, so that's what we call resonance. So in reality, remember how I said you could have chosen any one of these? In reality, this compound exists in 3 forms. It could have been like this, where we had that double bond, or I could have moved that double bond and had it within this oxygen. Or I could have done even another one. Where else could I have put that double bond?
On the bottom?
At the bottom. So all 3 of these are called resonance structures, and we'll talk more about that at a later time. Yes?
Are they all correct?
Yeah, they're all correct. So if you would have taken it from here, that would have been fine too. Yes. In fact, if you want the most correct answer, you'd have to draw all 3. But we're taking baby steps.
Wait, miss, before you move on.
Yes.
So how come the oxygen has
Okay, we'll talk about that. Good question. So, bless you. So at this point, is everybody clear on how I got to step 4? The only thing that I haven't mentioned, guys, please don't forget, if there's lone pairs on whatever atom we're looking at, please don't forget to continue drawing those lone pairs. Those lone pairs do not just go away. So oxygen had these 2 lone pairs. He's going to continue to have them every single time. The next question, is oxygen happy? Well, right now it looks like it has how many electrons? It looks like it has 4, right? 1, 2, 3, 4. But these 2 electrons, or excuse me, these 4 electrons are going to count for both oxygen and carbon. So 2, 4, 6, 8. Carbon has 2, 4, 6, 8. Make sense? Okay.
You're still not happy.
We're going, it is happy. Why is it unhappy?
Oh wait, I was thinking about Bohr model. Like valence electrons and all.
Oh, it is happy now because remember they're overlapping. Remember that Bohr model I showed you in yesterday's notes? Okay, excuse me. So go ahead and try and do the same thing with O2. I'll give you guys about a minute and then we'll work it out. So in order to do the 2 oxygens, I'm gonna follow the 4 steps. The first step is to just draw the structure of oxygen. So oxygen, oxygen. How many valence electrons does it have? 6. 1, 2, 3, 4, 5. And then I'm not gonna put the 6th one here just because it's gonna get in the way and I know I'm gonna bond. So I'm just gonna put it there, 6. 1, 2, oh, sorry, that was my mistake. 2, 3, 4, 5, 6. Okay, step 2 is to begin pairing unpaired electrons. So I'm just going to redraw it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. All right. Well, these 2 are unpaired, right? So we're gonna make that a bond. And these two are unpaired. So I'm gonna move both of these into the center, and that'll become a second bond. So I had two. I'm gonna take this little guy who's all by himself and this little guy who's all by himself, and then I'm gonna move both of them into the center.
So basically like your
Right. Yes.
So for the second step, you have the same amount?
Yeah, the same number. Whatever you start off with, that's what you're gonna end up with. You can't change the number of electrons. Yes.
Thanks.
The second oxygen, is that 5?
6. Oxygen has 6. 1, 2, 3, 4, 5, 6. That's a dot if you can't see it. Yeah. All right. Now, step 3 is to just draw the molecule, but now I'm gonna put these electrons in the middle. You guys, all the side conversations, can we please stop them? Thank you. All right. So I'm gonna start off with these two. 1, 2, and then these two. 1, 2. Thank you. So here I have my lone pairs. So this is one lone pair, so I'm going to make sure I draw it. And then here is another lone pair. I got to make sure I draw it. Again, a lone pair and another lone pair. Make sure that they don't go away. So far, so good?
yes.
Okay. The last thing I want to do is to replace my bonding pairs with lines. How many bonding pairs do I have? So how many lines should I draw? 2. But please make sure that you don't forget your lone pairs.
Don't forget them.
Don't forget them. And there we go. That is your final answer. KJ.
Do they have to be in pairs or do they like?
Yes, if it's not a bonding pair, you're not going to put a line.
No, like the leftover ones, the lone ones. Do they have to
Yes.
be in pairs or they can?
No, yes, please put your two. I mean, sometimes you'll see them not drawn like that, but the most correct way is to draw those two together.
There was
Haley.
2 dots.
Why don't they have
So
8?
those 2 that you made.
They do. So guys, let's make sure that we all satisfy the octet rule. So 1, 2, 3, 4, 5, 6,
Oh,
7,
those-
8.
Okay, sorry.
Remember that each
Yeah.
line represents 2 electrons, and then these electrons are being shared. He has 8, and he has 2, 4, 6, 8. Questions? Okay, so you can see that this is exactly what we just did.
Oh.
Okay, go ahead and try to do N2, the next one.
Oh, that was.
All right, we put nitrogen. There was 2 nitrogens, so I put 2 nitrogens. Here you can see each nitrogen has 5 because nitrogen is in group 5. 1, 2, 3, 4, 5. How many unpaired electrons does, you guys, please? How many unpaired electrons does each nitrogen have? 3. So how many bonds can each nitrogen make? 3. All right, well, I'm going to go ahead and pair up these 2. This one on the bottom can pair up with this one, and this one on the side can pair up with him. So there's 1, 2, 3 bonds. All right, so I just draw the electrons. So these 2 are right here in the middle. These 2, I'm going to put them in the middle now. And these 2 are going to go in the middle now. After I moved all of these, the only thing I have left is the lone pair. Well, there he is, and this lone pair. Questions? Okay, now each one of these pairs, so 1, 2, represents a line. So 1 line, 2 line, 3 lines, that's where I got those 3 lines from. Is anybody still feeling like we need some more explanation? Okay, go ahead and try, this is, by the way, this is what we just did. Go ahead and try the next one.
Yikes.